So continuing on, we had translated log base 5 of negative 25 equals n into negative 25, the power equals the base to the exponent. And if you remember, when we raise something to a power, if we raise it to a power bigger than 1, we get bigger and bigger numbers. 5 squared is 25, 5 cubed is 125, and so on. If we raise it to numbers less than 1, or less than 0 even, 5 to the negative 1 would be 1/5. 5 to the negative 2 would be 1/25. It never goes negative. So we say that log base 5 of negative 25 is undefined. There is no value for that. Just like you can't take the square root of a negative number, you can't take the logarithm of a negative number. Last one, let's sketch a reasonable graph of y equals log base 2 of x. We're going to do it this way. If we don't know what the log graph looks like, if I rewrite it this way as 2 to the y, not 2 to the 4, 2 to the y equals x, we know how to graph that kind of. We're not used to seeing the y in the exponent, but we can do this. Remember, we talked about this briefly, that when you find the inverse of something, you switch the x and the y. So that would be 2 to the x equals y is the inverse, and we certainly know how to graph that. So I'm going to start by graphing that particular function, and then we'll get back to the one we really want. So if 2 to the x equals y, I know several things. I know when x equals negative 1, y is a half. When x equals 0, y is 2. Y is 1. When x equals 1, y is 2. When x equals 2, y is 4, and it grows bigger and bigger that way. So it's going to look something like that. Remember, there's that asymptote along the x-axis, so it looks something like that. But because of that, then I know that the inverse, I just switch the ordered pairs around. So it'd be 1/2 comma negative 1, 1 comma 0, 2 comma 1, and 4 comma 2. So 1/2 comma 1 would be like right there. 1 comma 0, 1/2 comma negative 1. Goodness. 1/2 comma negative 1 would be down there. 1 comma 0 is there. 2 comma 1 would be right about there. 4 comma 2 would be out there somewhere. And remember also that if this asymptote is at y equals 0, then the asymptote for the original function has got to be x equals 0. And so I can sketch that one in like this. And that's what a logarithm graph looks like. In fact, all basic logarithm graphs look like that. So that's one way to graph y equals log base 2 of x. Think about what the inverse is. Think about what that graph looks like, and then graph the log graph. Thanks for participating. Try some of the homework problems now.